Hey guys, in this video we are going to be discussing something called end behavior. This is from section 4.1 and is a continuation in some ways of the previous video in which we talked about some different terms relating to polynomials. So today we're going to be looking at polynomials, their graphs first of all, and then looking at just the general equation and drawing some conclusions about something called the end behavior. So an end behavior, if you were to sort of define it, it would be basically what happens to the function as, we could say, as the x value gets really big, in other words, goes to infinity. This is what notation we're going to use as x goes to infinity. And as x gets really small, or you could say really negative. I'll say really negative. So in other words, as x goes to negative infinity. So what happens to the function, i.e. the y value, what happens to the y value of this function as x gets really big, in other words, it goes to positive infinity, and as x gets really negative or really small, in other words, as x goes to negative infinity. So I've got an example of one here. This is just some polynomial that's graphed. Notice it's continuous. We also would say that it's smooth. All polynomial graphs are going to look some way like this. They'll, be continuous the whole way. There should be no breaks in them. And all the little hills and valleys here are smooth, meaning there's no like sharp points on these. All right. So there's going to be two things we have to identify. What's happening as x goes this way. So this is what we're going to say as x goes to infinity. So in other words, as x gets bigger and bigger, which direction is the function going? Is the function going down to negative infinity, or is it going up to positive infinity? And as you can see, as x is going to the positive infinity, so we're moving positive x direction. The y direction of the function is going down, right? You can see that. So we're going to say f of x, which again is the same thing as saying y, in other words, y. Y is going down to negative infinity. So we say f of x, but it essentially just means y. So as x goes to positive infinity, f of x goes down to negative infinity. And if we were to look in the opposite direction, so if we're going sort of looking at this way, this would be as x goes to negative infinity. So as x values get smaller and smaller, which direction is the function going? And it's also going down, right? The y value is also going down. So we say that f of x goes to negative infinity in this case as well. So in either direction, as x goes to positive infinity, the y value, or f of x, goes down to negative infinity. And as x goes to negative infinity, the function value goes down to negative infinity in that direction as well. So the way that we're going to write this, you can see here as our options on Delta Math, we're always going to write this as two statements. We're going to say as x goes to a certain direction, so as x goes to negative infinity, what happens to our function? Well, we saw as x went to negative infinity, the function f of x goes to positive infinity, negative infinity. And then as x goes to positive infinity, sometimes I'll even put a little plus sign here just to make sure we denote the difference. F of x is also going to negative infinity. So when you're writing these statements, you're not going to actually have to write them, although if this was a book work assignment, you would need to write them. If you're actually writing these out, this part never changes, because we're always going to identify as x is going to negative infinity, what's happening to the function. And as x goes to positive infinity, what happens to the function. This part, the only part that's going to actually change is the signs of these. Signs may change. That's the only thing that changes. the f of x would actually be the same as well. You're always going to write f of x with a little arrow. That means goes to or tends to. And so the only thing that could possibly change would be these are either going to be negative or positive infinity in all these solutions. So our answer here is they're both going down to negative infinity. So let's identify the right one here. X goes to negative. Looks like this one here. All right. So we got as x goes to negative, f of x goes to negative. And as x goes to positive, f of x goes to negative. So that is our correct answer. Let's look at a couple more here. Go ahead and delete this stuff here. All right, so again, two things we have to identify. It's a good idea to write this out on your own as well. Try not to just maybe select it, but if you can write this out on a sheet of paper, it's good practice as well. So we're always going to look as x goes to positive infinity and as x goes to negative infinity. Where's the function going? And let's start with the negative one first. So we'd say as x goes to negative infinity, and all we're looking at is which direction is the function, meaning like the y value going. So we're looking at this up here. So as x goes to negative infinity, meaning like the left side of the graph, where is the function going? Well, it's going up. It's going up to positive infinity. So f of x goes to positive infinity. Okay, then we look the opposite direction. As x goes to positive infinity, again, those first part of the statements for both of them don't change. Well, where is the function going? So f of x goes to, and look up here, it's also going up to positive infinity. So that's our statement right there. Both are going up to positive infinity. So as x goes to negative, f of x goes to positive. As x goes to positive, f of x goes to positive. So it's going to be the last one here. Let's go ahead and look at one or two more here. So again, there's two things we have to identify. As x goes to negative infinity, what's happening? So as we move to the negative infinity direction, well, the function hasn't even actually made it over here yet. So we're just going to identify where the function is, the left side of the function, and it's clearly going down, right? Going down to negative infinity. So we'd say f of x goes to negative infinity. And then if we were to look as x goes to positive infinity, so as we're moving this way, the right side of the function, it's going up to positive infinity. So f of x goes to positive infinity. And then we just identify the statement there. It looks like they switched it around on us. So they put the positive one first. So we got as x goes to positive, y going to positive. Not that one. So it looks like this one here is x goes to positive, y to positive. X goes to negative, y to negative. So it's going to be this one. So you'd have to hunt around a little bit on these. Again, I would advise you write it out so you can match it up a little bit better. All right, so that is that. So sometimes they might go the same way, sometimes they might go opposite ways, but you'll definitely get the hang of it as you do some of these. So really you're just looking at sort of the two ends of the function. The left end, this tells you what's going to happen as x goes to negative infinity. This is the function going up to positive infinity or going down. And then this right side is going to tell you what happens as x goes to positive infinity. Just identify if the function is going down to negative infinity, which it would be in this one. So this would be as x goes to negative infinity. F of x is going up to positive infinity, right? And this one will be as x goes to positive infinity. F of x going down to negative infinity. So hopefully you're getting the hang of it there. Our next part of this assignment that we're going to be doing is looking at the function, except we're not going to be given a graph of it. We're going to be given the actual function, and then we have to make these same determinations. So we're going to flip back here a sec and look at the next one. This is called the end behavior algebraically. So the previous one was in the end behavior graphically, and this one is algebraically. So when we do this, there's going to be 4 options. If you kind of think through the combinations, the 4 options that you could have would be a function, both of them going to positive, both of them going to negative, one going negative in the positive and negative, say positive in the positive, negative in the negative, and the opposite of that, negative in the positive and positive in the negative. So anyway, there's 4 options here. And how we're going to determine what happens in this is we're just going to look at the biggest term, meaning sort of the leading term. If you remember from the last video, the leading term is the one with the highest degree. And we want the whole term, not just the exponent. We want the whole term. So it's the term with the highest degree there, which is negative 2x to the 4th. And this term determines what's going to happen to our function. It turns out all this other stuff, it matters what happens in the middle, but it does not affect the end behavior. So the end behavior is determined solely by the leading term, meaning the term with the highest exponent. So that leading term tells us everything we need to know about the end behavior. It doesn't tell us everything that happens with the function. It doesn't tell us what happens in all the middle, but it does tell us what's going to happen on both ends as x goes to positive infinity and x goes to negative infinity. So there's I'll make a little chart here for you. With this term, we have a few different options. This exponent could either be an even exponent, which in this case 4 is even, or it could be an odd exponent like 3 or 5. And this number in front could either be a positive number or it could be a negative number. So those are going to be the 4 things that determine this end behavior, whether the exponent is positive or negative, and whether the coefficient is negative or positive. So if we were to just sort of take some basic parent functions, let's say, I'm just going to do very basic, let's say x squared. So this would be, let's say 2x squared. Okay. So that one is going to just basically look something like this. It's a U shape. But this would be the case if I had like, I don't know, 5x to the 5th would still have this same end behavior. At the 2 ends, it's going to go up to positive infinity. If I were to just make this negative, let's say negative 2x squared, well, then it's just going to flip it upside down. So now my 2 ends are both going down to negative infinity for the end behavior. Now, if I were to do an odd exponent, let's say x cubed, okay, so if I were to do 2x cubed, well, that's going to look like this. So the end behavior is going to be positive in the positive and negative in the negative. And then let's say I put a negative in front of that 2, negative 2x cubed. It's going to flip it. So now it's going to look like this. So it's going to go positive in the negative and negative in the positive. And these are the 4 possibilities that we could have. We could have both positive, both negative, or opposites, depending on which situation you have there. Those are the 4 possibilities. These possibilities will be the same no matter if that 2 is a 10 or the x squared is an x to the 4th or an x to the 6th. What we're looking at is an even versus odd exponent and the sign of the leading coefficient. So I'm going to make a little chart. The first one is going to be if we have an even power, and we'll do a positive. It might be helpful to write this little chart down. So even power positive, which is what we have in that 2x squared. So example, 2x squared. And actually, I'm going to go ahead and clear the rest of this stuff out real quick. Start from scratch. I got a little more room. All right. So the first one is going to be an even. I want to say even / positive. So example, f of x equals 2x squared. That's an even exponent. It could be 2, it could be 4, 6, whatever, and it's a positive leading coefficient of 2. Okay, so what this function looks like is something like this, right? So the end behavior of this is going to be positive in both directions. So as x goes to positive infinity, f of x goes to positive infinity, right? And also as x goes to negative infinity, f of x goes to positive infinity in that direction as well. Both directions it goes to positive infinity. So that's our first scenario. The second one, let's do an even, talking about the exponents, and a negative, even negative. So that would just be a f of x equals negative 2x squared. And as we talked about, this is just going to flip it like that, right? So then this would be as x goes to positive infinity. The function now is going down to negative infinity. So f of x goes to negative infinity. And as x goes to negative infinity, f of x goes down to negative infinity as well. So those are the first two scenarios. Those are even exponents. Notice evens always go the same direction. Odds are always going to go the opposite direction. So let's say if I have an odd and positive next. So the example would be positive 2x squared, 2x cubed. And again, this would be the case if it was next to the fifth or next to the seventh, so on and so forth. So this one's going to have this basic shape here. So we would say as x goes to positive infinity, f of x is going to go to positive infinity as well, right up here. And then as x goes to negative infinity, the function is also going to go down to negative infinity. So they go the same direction. And last but not least, if we have an odd and a negative, for example, f of x equals negative 2x cubed, that's going to get flipped. Looks something like this. So they're both the opposite. As x goes to positive, f of x goes to negative. And as x goes to negative, f of x goes to positive. I would write this chart down. It's going to be very helpful for solving all of these. Ultimately, though, you do have to be able to do this without the chart, but it is very helpful in learning it. So when we're doing this, we're just going to basically identify the leading term, and then identify if it's an even exponent or odd exponent, and if the coefficient there is in positive or negative. And then we can identify the end behavior without even looking at the graph of it. All right, so in this first one, we identified the leading term as negative 2x to the fourth. So that is an even because it's 4, even negative. All right, so even negative means they're both going to go down to negative infinity. So as x goes to positive, f of x is negative. And as x goes to negative, f of x is also negative. So that's going to be this one right here. Both going down to negative. And some of my chart disappeared there, which I thought might happen, but we should still be able to, oh, there we go. All right. So hopefully you wrote that chart down. Again, that it will be very helpful in doing this assignment. If not, just rewind the video and write it down. All right, next one, let's identify the leading term. So our highest power here is 6x to the third. Notice I circled the sign that goes with it as well. It's a positive and it's an odd. So this is an odd because the exponent's odd, odd positive. We're not looking at, one common mistake is to look at the 6 and say, well, that's even. That's not what we're talking about. We're talking about an odd power. So make sure you get the odd power and then a positive leading coefficient. All right, so odd and positive, that means they're going to go the same direction. So positive x, function goes to positive, and negative x, the function goes negative. So that's what we're going to look for. And actually in this one, notice it uses y instead of f of x for whatever reason. I'm not sure why. But f of x and y can be used interchangeably. So, all right, so negative, negative, and positive, positive. That will be first one. And you can see here, it's just using the parent function there. It says this has the same end behavior as simply just x cubed. And so you can always remember, watch those. Here's the actual graph. You can see it there. It doesn't we don't actually need it, but just sort of an FYI to show you what we said is true. Remember, there always is these help videos too if you want to see it explained in probably a slightly different way. All right, let's go ahead and try one or two more here. This one's the same as the last one, so let me do another one. All right, this one, highest power is cubed, and it's negative. So that's an odd power and a negative. So odd, negative, that one is going to imply the opposites. So as x goes to positive, f of x goes negative, and as x goes negative, f of x goes positive, based on this chart over here. Right, just look at this chart. All right, so let's identify the correct one there. So let's see, this one looks like that one, right? Negative goes to positive, and positive goes to negative. All right, and last one, why don't you go ahead and try this one? So we're looking at this term, negative 6x squared. This would be an even power and negative. Even and negative looks like this. I always just try to visualize what the shape of the function is, and then it's fairly easy to figure out. So both are going to negative. As x goes to positive, f of x is going negative. And as x goes negative, f of x is going negative. So down here. And that will do it. So be sure to, again, always reach out to me if you are still struggling with this. Remember, there is these help videos and these solutions as well. All right, good luck.